Hello all, let us try to understand the signal integrity workflow um, that is followed by the simulation engineers in the industry. So the first thing when we talk about the signal integrity, or basically well before that, if we talk about a product design, the major input are the product requirements, right? So the stakeholders that are there for the project and the engineers who are involved in the project do sit together and perform a brainstorming session before um, starting the project, and they do brainstorm the requirements and come up with various scenarios, or any dependencies, or any technology related issues, or any gaps with respect to capabilities. And one important um, analysis during that requirement phase is identifying the signal integrity requirements. So a signal integrity engineer being part of that meeting um, helps the team understand the requirement to perform simulations based on the requirements that are there. And then the integrity engineer continues to project the tools that can be used, whether it be 2D or 3D field solvers, based on the requirements of the project, or based on the expertise that is there in the company. And then he starts working on the major chips which are to be used as a part of the requirements. Basically, he might not identify the chips, but during the architecture phase, definitely we will have the major chips to be used, right? So he uh, takes them into consideration. The signal integrity engineer takes them into consideration, and then gets the models from the vendors, and in parallel he also identifies the list of nets that need to be simulated. So this is where a PCB is not ready, a schematic is not ready, but the signal integrity engineer starts involving and getting the inputs um, from the design engineer, and gathering all the simulation related requirements. And this is the phase where he does a pre-layout simulation. So pre-layout simulation basically helps the signal integrity engineer, the design engineer, basically the circuit design engineer, and also the PCB layout engineer to understand what kind of um, uh, considerations to be taken in the circuit design as well as the layout design. So this is where all the termination related requirements, or the impedance related requirements, all the trace widths, all the spacing between the traces, all these can be decided in the pre-layout simulation. So pre-layout simulation is a very key aspect. So for pre-layout simulation, there are three four things that are required. The first thing is the stack up need to be decided. That means the number of layers as well as the material to be used in the stack up need to be finalized. And then the layout constraints. So layout constraints are like which layers we are going to route, what are the impedances required, what are the wires that are being planned in the layout, and which layers the routing is going to happen, how will be the plane. So all these constraints, and then spacing between the traces, all these need to be input to the signal integrity engineer. And then one more important aspect while he gets these inputs is a signal integrity engineer cannot directly use the model that is being provided by the manufacturers. He has to validate the model. That means he has to look into the model, see what are all the uh, basic deviations that are present in the model, and see if model requires some modifications from his end. So a signal integrity engineer is also well familiar with the S parameter models, with the IBIS models, and he knows the in and out of those models, the IO buffering requirements, the voltage levels. So these basic things need to be known by the signal integrity engineer. And then the layout constraints, the PCB layout stackup, validating the model, all these combined together, he does the pre-layout simulation, and he gives the suggestions, and further the constraints are being generated for the actual PCB layout, which will be based on the pre-layout simulation results, and the kind of inputs that are required for routing the PCB. So once this is done, the post layout analysis, the PCB layout will be completed, and again the signal integrity engineer will be performing simulation on the layout that is being designed by the PCB layout engineer, which we call post layout analysis. So once the post layout analysis is done and the results are generated, signal integrity engineer mostly looks into the timing related aspects, and then the waveform integrity, how it is, and decides on the terminations by employing various values of terminations and coming up with the appropriate value of the termination that need to be used in the circuit, and that will be passed to the schematic engineer, and correspondingly they get imported into the layout. So there will be few iterations between layout engineer, schematic engineer, and the signality engineer during the design phase, and it's a cycle where they come to a common conclusion based on the simulation results that yes, this timing looks good, and the signal looks good, integrity has been maintained for the signal, and then they release the PCB layout. Now the, the signal integrity engineer's role should not just stop with this. He should also follow up on the kind of testing that is being done on the PCB, and always look towards capturing the waveforms and comparing the timing related aspects with the simulation results, and see how closely they are matching. And these inputs help the signal integrity engineers gain knowledge and also get to know the loopholes while performing the simulations, and get them corrected in the next simulation projects. So a very very important aspect, the last one. Okay, so this is how the signal integrity project flow happens, and as we see, signal integrity engineer plays a very crucial role from the stage where we have the requirements till the stage where validation has been completed and results have been analyzed. So this is a very very crucial role in a company where people do create complex PCBs, especially high speed related aspects. If there is a deviation from what we have talked here, and if you follow a different process, please post in the comments. And remember that we only talked about the timings, the impedance aspects. Here there is also power integrity that is associated, which basically analyzes the power distribution network, PDN, of the PCB. So that we will cover in the later videos. Thank you.